Hi everyone, my name is Ivailo and I am the CTO of NitroPack. There seems to be a lot of confusion around how our resource loading works, so I decided to make this quick video explaining the most confusing part, which would be the number of resources and their size. We will use our own website for the purposes of this demo, but the same is true for any website optimized by NitroPack. Let's reload the page and see what happens. Now, let's examine what kind of resources are loaded. We have the blank images. They are used as placeholders when doing image lazy loading. We have the actual images, CSS files, JavaScript files, and some fonts. Basically, all that we need in order to display the website. However, looking closely, you may notice some unusual things. For example, this CSS file is loaded twice. Some files have a cogwheel next to them. Others are empty. So what's going on? Well, I'm glad you asked. This is all expected behavior on optimized pages, so let's go over what happens here. The empty files are not actually empty. The size column in the network inspector simply displays the transferred size, but hovering over the provided number displays the loaded file size as well. So for this resource, we can see that it's actually 800 bytes. The zero file size can be observed for files that have been delivered as part of the HTML content of the page, so no additional transfers happened. The cogwheel indicates that this request was made by a web worker. All resources that have the cogwheel are being transferred over the network, so they have some non-zero length. For example, this CSS file is 39 kilobytes. Once the resource is fully transferred and ready to be loaded, NitroPack will then let the browser know and load the file. This is how we get duplicates like that. First, the file gets transferred, then it gets loaded. This is true for both CSS and JavaScript. The benefit of this is that while the resource is loading in the background, the browser will be free to do other stuff, like paint the website, for example. A similarly non-blocking effect can also be achieved in other ways, where a common technique is to simply load the CSS with a non-matching media attribute or use preload links. However, this might not be optimal. Doing it like that sets the highest priority for this file, even though the critical CSS is already available and our hero image is actually more important. Doing the preload like we do allows for giving certain resources more or less priority. Being able to suggest the browser what the resource priority is something that is already being discussed as a new feature to be added in the browsers in the form of the importance attribute, because it's actually useful to be able to do that. As for the total number of resources, you will always get less resources after an optimization. After all, combining multiple resources into one or lazy loading resources that are not needed are some of the oldest techniques for site speed optimization. Measuring the number of requests should always give you a lower number of resources after a good optimization. Even though HTTP2 made great progress in terms of efficiency over the network, it is still beneficial to make fewer requests, because it simply means that unnecessary resources are not being loaded. Take image lazy loading, for example. Reducing the number of requests because hidden images do not need to be downloaded can have a huge impact. And that's it. Thank you for listening, and I hope you found this video helpful.